Hi, this is Lance from LangChain. This is a talk I gave at two recent meetups in San Francisco called "Is RAG Really Dead?" And I figured since a lot of people actually weren't able to make those meetups, I just record this and put this on YouTube and see if this is of interest to folks. Um, so we all kind of recognize that context windows are getting larger for LLMs. So on the x-axis, you can see the tokens used in pre-training. That's of course getting larger as well. Proprietary models are somewhere over the 2 trillion token regime. We don't quite know where they sit. And we've all the way down to smaller models like 5.2 trained on far fewer tokens. But what's really notable is on the y-axis, you can see about a year ago, state-of-the-art models were on the order of 4,000 to 8,000 tokens, and that's, dozens of pages. We saw Claude 2 come out with a 200,000 token model earlier, I think it was last year. GPT-4 with 128,000 tokens. Now that's hundreds of pages. And now we're seeing Claude 3 and Gemini come out with million token models. So this is hundreds to thousands of pages. So because of this phenomenon, people have been kind of wondering, is RAG dead? If you can stuff, many thousands of pages into the context window of an LLM, why do you need a retrieval system? It's a good question. It sparked a lot of interesting debate on Twitter. And it's maybe first just kind of grounding on what is RAG. So RAG is really the process of reasoning and retrieval over chunks of information that have been retrieved. It's starting with documents that are indexed. They're retrievable through some mechanism, typically some kind of semantic similarity search or keyword search, other mechanisms. Retrieved docs are then passed to an LLM, and the LLM reasons about them to ground response to the question in the retrieved document. So that's kind of the overall flow. But the important point to make is that typically it's multiple documents and involves some form of reasoning. So one of the questions I asked recently is, if long context LLMs can replace RAG, it should be able to perform, multi-fact retrieval and reasoning from its own context really effectively. So I teamed up with Greg Cameron to kind of pressure test this. And he had done some really nice needle in the haystack analyses already, focused on kind of single facts called needles placed in a haystack of Paul Graham essays. So I kind of extended that to kind of mirror the RAG use case or kind of the RAG context, where I took multiple facts. So I call it multi-needle. I built on a funny needle in the haystack challenge published by Anthropic, where they basically placed pizza ingredients in the context and asked the LM to retrieve this combination of pizza ingredients. I kind of riffed on that, and I basically split the pizza ingredients up into 3 different needles and placed those 3 ingredients in different places in the context, and then asked the LLM to recover those 3 ingredients from the context. So again, the setup is, the question is whether the secret ingredients need to build a perfect pizza. The needles are the ingredients: figs, prosciutto, goat cheese. I place them in the context at some specified intervals. So the way this test works is you can basically set the percent of context you want to place the first needle, and the remaining 2 are placed at roughly equal intervals in the remaining context after the first. So that's kind of the way the test is set up now. It's all open source, by the way. The link is below. So the needles are placed. You ask a question, you prompt LLM with kind of with this context in the question, and then produces the answer. And now the framework will grade the response. Both, one, are all the specified ingredients present in the answer, and 2, if not, which ones are missing. So I ran a bunch of analysis on this with GPT-4 and came up with some fun results. So you can see on the left here, what this is looking at is different numbers of needles placed in a 120,000 token context window for GPT-4. And I'm asking GPT-4 to retrieve either 1, 3, or 10 needles. Now, I'm also asking it to do reasoning on those needles. That's what you can see in those red bars. So green is just retrieve the ingredients, red is reasoning, and the reasoning challenge here is just return the first letter of each ingredient. So we find is basically 2 things. The performance, or the percentage of needles retrieved, drops with respect to the number of needles. That's kind of intuitive. You place more facts, performance gets worse. But also it gets worse if you ask it to reason. So if you say, just return the needles, it does a little bit better than if you say return the needles and tell me the first letter. So you overlay reasoning. So this is the first observation. More facts is harder. and reasoning is harder than just retrieval. Now, the second question we ask is, where are these needles actually present in the context that we're missing, right? So we know, for example, retrieval of 10 needles is around 60%. So where are the missing needles in the context? So on the right, you can see results telling us actually which specific needles the model fails to retrieve. So what we can see is, as you go from 1,000 tokens up to 120,000 tokens on the X here, and you look at needle 1 placed at the start of the document to needle 10 placed at the end, at 1,000 token context length, you can retrieve them all. So again, kind of match what we see over here. Over here, everything I'm looking at is 120,000 tokens. So that's really not the point. The point is actually smaller context, better retrieval. So that's kind of point one. As I increase the context window, I actually see that there is increased failure to retrieve needles, which can see in red here, towards the start of the document. And so this is an interesting result. And it actually matches what Greg saw with single needle case as well. So the way to think about it is, it appears that if you, for example, read a book and I ask you a question about the first chapter, you might have forgotten it. Same kind of phenomenon appears to happen here with retrieval, where needles towards the start of the context are kind of forgotten or are not well retrieved relative to those at the end. So this is an effect we see with GPT-4. It's been reproduced quite a bit. So I ran 9 different trials here. Greg's also seen this repeatedly with single needle. So it seems like a pretty consistent result. And there's an interesting point. I put this on Twitter, and a number of folks, replied, and someone sent me this paper, which is pretty interesting. And it mentions recency bias as one possible reason. So the most informative tokens for predicting the next token, are present close to or recent to kind of where you're doing your generation. And so there's a bias to attend to recent tokens, which is obviously not great for the retrieval problem, as we saw here. So again, the results show us that reasoning is a bit harder than retrieval, more needles is more difficult, and needles towards the start of your context are harder to retrieve than towards the end. Those are the 3 main observations from this. And it may be indeed due to this recency bias. So overall, what this kind of tells you is, be wary of just context stuffing in long context LLMs. There are no retrieval guarantees. And also, there's some recent results that came out actually just today, suggesting that single needle may be misleadingly easy. There's no reasoning. It's retrieving a single needle. And also, these guys, I showed this tweet here, show that in a lot of these needle in the haystack challenges, including mine, the facts that we look for are very different than the background kind of haystack of Paul Graham essays. And so that may be kind of an interesting artifact. They note that, indeed, if the needle is more subtle, retrieval is worse. So I think basically when you see these really strong performing needle in the haystack analyses put up by model providers, you should be skeptical. You shouldn't necessarily assume that you're going to get high quality retrieval from these long context LLMs for numerous reasons. You need to think about retrieval of multiple facts. You need to think about reasoning on top of retrieval. You need to think about the subtlety of the retrieval relative to the background context, because for many of these needle in the haystack challenges, it's a single needle, no reasoning, and the needle itself is very different from the background. So anyway, those may all make the challenge a bit easier than a real world scenario of fact retrieval. So I just want to kind of lay out those cautionary notes. But, I think it is fair to say this will certainly get better. And I think it's also fair to say that RAG will change. And this is just like really not a great joke, but Frank Zappa, musician, made the point, jazz isn't dead, it just smells funny. I think same for RAG. RAG is not dead, but it will change. I think that's kind of the key point here. So just as a follow-up on that, RAG today is focused on precise retrieval of relevant doc chunks. So it's very focused on typically taking documents, chunking them in some particular way, often using very idiosyncratic chunking methods. Things like chunk size are kind of picked almost arbitrarily, embedding them, storing them in an index, taking a question, embedding it, doing KNN similarity search to retrieve relevant chunks. You're often setting a K parameter, which is the number of chunks you retrieve. You often will do some kind of filtering or post-processing on the retrieved chunks, and then ground your answer in those retrieved chunks. So it's very focused on precise retrieval of just the right chunks. Now, in a world where you have very long context models, I think a fair question to ask is this really kind of the most reasonable approach? So kind of on the left here, you can kind of see this notion closer to today of I need the exact relevant chunk. You can risk over engineering. You can have higher complexity, sensitivity to these odd parameters like chunk size, K, and you can indeed suffer lower recall because you're really only picking very precise chunks. You're beholden to very particular embedding models. So, I think going forward, as long context models get better and better, there are definitely you should certainly question the current kind of very precise chunking RAG paradigm. But on the flip side, I think just throwing all your docs into context probably will also not be the preferred approach. You'll suffer higher latency, higher token usage. I should note that today, 100,000 token GPT-4 is like $1 per generation. I spent a lot of money on LangChain's account on that multi-needle analysis. I don't want to tell Harrison how much I spent. So it's not good, right? You can't audit retrieval. And security and authentication are issues if, for example, you need different users, different access to certain kind of retrieved documents or chunks. In the context stuffing case, you kind of can't manage security as easily. So there's probably some Pareto optimal regime kind of here in the middle. And, I put this out on Twitter. I think there's some reasonable points raised. I think, this inclusion at the document level is probably pretty sane. Documents are self-contained chunks of context. What about document-centric RAG? So no chunking, but just like operate on the context of full documents. So, if you think forward to the RAG paradigm that's document-centric, you still have the problem of taking an input question, routing it to the right document. This doesn't change. So I think a lot of methods that we think about for kind of query analysis, taking an input question, rewriting it in a certain way to optimize retrieval, things like routing, taking a question, routing it to the right database, be it a relational database, graph database, vector store, and query construction methods. So for example, text to SQL, text to Cipher for graphs, or text to even like metadata filters for vector stores. Those are all still relevant in the world that you have long context LLMs. You're probably not going to dump your entire SQL DB and feed that to the LLM. You're still going to have SQL queries. You're still going to have graph queries. You may be more permissive with what you extract, but it still is very reasonable to store the majority of your structured data in these forms. Likewise, with unstructured data like documents, like we said before, it still probably makes sense to store documents independently, but just simply aim to retrieve full documents rather than worrying about these idiosyncratic parameters like chunk size. And along those lines, there's a lot of methods out there. We've done a few of these that are kind of well optimized for document retrieval. So one I want to flag is what we call multi-representation indexing. And there's actually a really nice paper on this called dense X retriever or proposition indexing. But the main point is simply this. What you do is you take your raw document, you produce a representation, like a summary of that document, you index that summary, right? And then at retrieval time, you ask your question, you embed your question, and you simply use a high-level summary to just retrieve the right document. You pass the full document to the LLM for kind of final generation. So it's kind of a nice trick where you don't have to worry about embedding full documents in this particular case. You can use kind of very nice descriptive summarization prompts to build descriptive summaries. And the problem you're solving here is just get me the right document. It's an easier problem than get me the right chunk. So this is kind of a nice approach. There's also different variants of it, which I share below. One is called parent document retriever, where you could use, in principle, if you wanted, smaller chunks, but then just return full documents. But anyway, the point is preserving full documents for generation, but using representations like summaries or chunks for retrieval. So that's kind of like approach one that I think is really interesting. Approach two is this idea of RAPTOR. It's a cool paper, came out of Stanford somewhat recently, and this solves the problem of what if for certain questions I need to integrate information across many documents. So what this approach does is it takes documents and it embeds them and clusters them, and then it summarizes each cluster. And it does this recursively until you end up with only one very high-level summary for the entire corpus of documents. And what they do is they take this kind of this abstraction hierarchy, so to speak, of different document summarizations, and they just index all of it. And they use this in retrieval. And so basically, if you have a question that draws in information across numerous documents, you probably have a summary present and indexed that kind of has that answer captured. And so it's a nice trick to consolidate information across documents. Their paper actually reports, these documents in their case, or the leafs, are actually document chunks or slices. But I actually showed, I have a video on it in a notebook, that this works across full documents as well. And that's a nice segue into, to do this, you do need to think about long context embedding models because you're embedding full documents. And that's a really interesting thing to track. Hazy Research put out a really nice blog post on this using with the Monarch Mixer. So it's kind of a new architecture that attends to longer context. They have a 32,000 token embedding model that's available on Together AI. Absolutely worth experimenting with. I think this is a really interesting trend. So long context embeddings kind of play really well with this kind of idea, where you take full documents, embed them using, for example, long context embedding models, and you can kind of build these document summarization trees really effectively. So I think this is another nice trick for working with full documents in the long context kind of LLM regime. One other thing I'll note, I think there's also going to move away from kind of single shot RAG. Well, today's RAG, we typically, we chunk documents, embed them, store them in an index, do retrieval, and then do generation. But there's no reason why you shouldn't kind of do reasoning on top of the generation or reasoning on top of the retrieval and feed back if there are errors. So there's a really nice paper called Self-RAG that kind of reports this. We implemented this using LangGraph, works really well. And the idea is simply to grade the relevance of your documents relative to your question first. If they're not relevant, you rewrite the question. You can do many things. In this case, we do question rewriting and try again. We also grade for hallucinations. We grade for answer relevance. But anyway, it kind of moves RAG from a kind of single shot paradigm to a kind of a cyclic flow in which you actually do various gradings downstream. And this is all relevant in the long context LLM regime as well. In fact, you absolutely should take advantage of, for example, increasingly fast and performant LLMs to do these grading. Frameworks like LangGraph allow you to build these flows, which allows you to kind of have a more performant kind of self-reflective RAG pipeline. Now, I did get a lot of questions about latency here, and I completely agree. There's a trade-off between kind of performance, accuracy, and latency that's present here. I think the real answer is you can opt to use very fast, for example, models like Grok we're seeing, GPT-3.5 turbos very fast. These are fairly easy grading challenges. So you can use very, very fast LLMs to do the grading. And for example, you can also restrict this to only do one turn of a kind of cyclic iteration. So you can kind of restrict the latency in that way as well. So anyway, I think it's a really cool approach, still relevant in the world as we move towards longer context. So it's kind of like building reasoning on top of RAG in the generation and retrieval stages. And a related point, one of the challenges with RAG is that your index, for example, you may have a question that asks something that's outside the scope of your index, and this is kind of always a problem. So a really cool paper called C-RAG or corrective RAG came out, a couple months ago that basically does grading, just like we talked about before. And then if the documents are not relevant, you kick off and do a web search and basically return the search results to the LM for final generation. So it's a nice fallback in cases where the question's out of the domain of your retriever. So, again, nice trick, overlaying reasoning on top of RAG. I think this trend, continues because, it makes RAG systems, more performant and less brittle to questions that are out of domain. So, that's another kind of nice idea. This particular approach also we showed works really well with open source models. So I ran this with Mistral 7B. It can run locally on my laptop using Ollama. So again, really nice approach. I encourage you to look into this. And this is all kind of independent of the LLM kind of context length. These are reasoning you can add on top of the retrieval stage that can kind of improve overall performance. And so the overall picture kind of looks like this, where, I think that the problem of routing your question to the right database and or to the right document kind of remains in place. Query analysis is still quite relevant. Routing is still relevant. Query construction is still relevant. In the long context regime, I think there is less of an emphasis on document chunking. Working with full documents is probably kind of more Pareto optimal, so to speak. There's some clever tricks for indexing of documents, like the multi-representation indexing we talked about. The hierarchical indexing using RAPTOR that we talked about as well are two interesting ideas for document-centric indexing. And then kind of reasoning and generation post-retrieval on retrieval itself to grade, on the generations themselves, checking for hallucinations. Those are all kind of interesting and relevant parts of a RAG system that I think we'll see more and more of as we move more away from like a more naive prompt response paradigm, more to like a flow paradigm. We're seeing that actually already in code generation. It's probably going to carry over to RAG as well, where we kind of build RAG systems that have kind of a cyclic flow to them, operate on documents, use long context LLMs, and still use kind of routing and query analysis. So reasoning pre-retrieval, reasoning post-retrieval. So anyway, that was kind of my talk. And yeah, feel free to leave any comments on the video and I'll try to answer any questions. But yeah, that's probably about it. Thank you.